A curve C is defined by these parametric equations: x equal t squared, y equal t cubed minus 3t. Show that C has two tangents at the point 3, 0 and find their equation. So we'll start there. So if we want the tangents, we are going to want dy dx, which equals dy dt. So derivative of y here with respect to t is 3t squared minus 3 over dx dt, which is 2t. But we are interested in figuring out at the xy point 3 and 0, so we need to figure out what t is at that point. So if we come up here, if we want the x to be 3, the t is going to need to be plus or minus square root of 3. So we know that this is going to occur when t equals plus or minus square root of 3. So let's go ahead and evaluate this at positive square root of 3. So square root of 3 squared is 3, times 3 is 9, minus 3 is 6. So that's going to be 6 over 2 square roots of 3. And if we actually rationalize that, multiply top and bottom by square root of 3 and simplify, that's just simply going to be square root of 3 then. So, alright, so the slope of the tangent to the curve at the point 3, 0 is square root of 3, or if we put in negative square root of 3, we're going to get the same thing out for the numerator. We're going to get a negative in the denominator, so the other possibility would be negative square root of 3. So that's interesting. At this point, there is a positive slope tangent and a negative slope tangent. So that tells us the curve must cross itself there. And we could go ahead then and figure out that point. It has to be where the point where x equals 3 and y equals 0. So our equations of our tangents, I'm trying to figure out where to put them on the screen. I'm going to put them right up here. Is going to be y equal plus or minus square root of 3 for our slope, and then x minus 3 using the point slope formula in this point right here. So we have those two tangents. Now part B, find the points on the curve where the tangent is horizontal or vertical. So first of all, we could figure out the horizontal by figuring out when dy dt equals 0, and that would be the 3t squared minus 3. So we'll go ahead and factor the 3 out, and that'll leave us t squared minus 1, which will factor into t plus 1, t minus 1. We're interested in where that equals 0. So it looks like there's two places where the tangent is horizontal, when t equal negative 1 and when t equal 1. So this is our horizontals, and we could substitute those in to figure out at what point that would happen. So if t were negative 1, negative 1 squared is 1, so that's going to be at the point 1, and this would be negative 1 plus 3, so at the point 1, 2. Now if t were 1, that's going to be at the point 1 and negative 2. So we've got horizontal tangents at both of those points. Now we also need to look for vertical tangents. Vertical tangents would be when the dx dt, which is the denominator here, equals 0. So that would be when t equals 0. So vertical would be when t equals 0, and so that would be at the point 0, 0. So vertical tangent at the origin. Now part C, determine where the curve is concave up or concave down. So if we want to determine where the curve is concave upward or concave downward, we're going to look at the second derivative of dy dx. So we essentially want the second derivative, and that is going to be the derivative with respect to t of dy dx and then over dx dt. So here's our dy dx right here, and if we take the derivative of that, it might be easiest to express this as, we'll split this up and have 3 halves t minus 3 halves over t. So if we take a derivative here, we're going to have 3 over 2 minus 3 over 2t squared, but that'll become a plus, and then that's going to be over dx dt, which was 2t. Now to simplify this a little bit, we can make these both t squareds, and then we can take this and flip it over and multiply. So we're going to get 3t squared plus 3 over 4t cubed. So if we're interested in where it's concave up or concave down, this numerator is always going to be a positive number. So we're only going to change concavity if we change the sign of the denominator, and that's going to happen if t is greater than 0, we're going to get a positive second derivative. If t is less than 0, we will have a negative. So we have t greater than 0, concave up, and t less than 0, concave down. Okay, let's put these pieces together then and see if we can get an idea of what this graph might look like. We have at the point 0, 0, there's going to be a point on there, and there's going to be a vertical tangent there. At the point 3 and 0, we are going to have tangents to the curve along these lines. So they were going to look something like this for our tangents to the curve there. And then we're going to have horizontal tangents at the point 1, 2. So at 1, 2, we are going to have a horizontal tangent. Let's put that in another color, horizontal tangent. And at the point 1, negative 2, we're also going to have a horizontal tangent. And then we had the vertical tangent at 0. So let's put this information together. At t equals 0, we were here at the origin, 0, 0. And then we can see that at t equal 1, we're at negative 2. So we can come around here, and then we have that horizontal tangent, and we should be, because we're greater than 0, concave up. So we've got that coming around here. And then we would continue with concave up, and here was a tangent to the curve right here. So these other values here, we have where t is less than 0, concave down, and if we had t being negative 1, we're at the point 1, 2. So you can see we'd move around the curve this way. If we kind of backed up the other way, we would get the rest of the curve for our negative t's. And so it looks like it would come around here, something like this. So there's where our concave down is. Here's where our concave up is. So let's see how we did. Here is the graph of the curve. And you can see that at our key points that we had here, we have our horizontal tangents, our vertical tangent, and our tangents here that look like that square root of 3 times the quantity x minus 3, and negative square root of 3 times the quantity x minus 3.